Hey, before I start the video, I would like to say thank you to Wago Japan and Manufacturing Works. In this video, we have the CANOPEN coupler 750V47. CANOPEN coupler is supported by Wago Japan, and the Schneider PLC TM241 is provided by Manufacturing Works. I really want to say thanks of you. Thank you.
Hello FM, I'm Chris. In this video, I will show you how to use Schneider PLC TM241 and Wago CANOPEN coupler 750347 to configure a CANOPEN network. Let's start. Okay, here is the configuration in my tutorial. In the left hand side, here's the Schneider CPU TM241. They have a CANOPEN interface in here. And this side is the Wago coupler 750347. And they connect the CANOPEN interface. They connect in this yellow, it's orange terminal. And here is the analog simulator. Therefore, me to open the analog signal from 0 to 10 volt to the Wago analog input I/O slot. That to check the signal is really coming inside the module or not. Let's start.
Okay, now it's the time to configure our project. As I mentioned before, TM241 is Schneider PLC is used in this tutorial. So you need to install the Machine Expert Logic Builder. But I also bring the links that you can download and install this software, so don't worry. Okay, before we start to configure the CANOPEN coupler from Wago, we need to download the EDS file to configure, then install in this engineer tube. You can go to, I will also place the link in the end of the video descriptions, and when you exit the link, you jump to this Wago global page and just scroll down and go to download, and here is the device description file. Just download it to your OS. Okay, go back to our Schneider engineer tubes, go to File, New Project, and choose your CPU type, enter your project name, press OK. And basically second, now it's creating your new project. Done. Okay, now the project is great. The first thing is you need to install the EDS file. Go to Tubes, Device Visibility, and install. And after you download the EDS file, the zip file from Wago homepage, you unzip a folder like 750.914, something like this. And when you click inside, there's a 750347. This is the CANOPEN coupler that you're using in this tutorial. Select all and just open to install the file. That take you 5 seconds something. Okay, the first one you need to configure a CANOPEN master. And go here, CAN_1, right click, add device, open the CANOPEN End Manager. And here is our CAN master. It's CANOPEN performance. Just edit. Done. And then we need to just click the CANOPEN performance. And here we can filter the vendor. And here in the vendor, we just choose Wago. In the feed types of CANOPEN coupler, just choose the first one, add device. Done. Now then you configure the CANOPEN master and a slave. Now we can configure the I/O slot that is installed in your 750347. Okay, I have a small notes. The first one is 7501417. Let's go to Swing for Search 1417. Click it, add device. Easy. Next one is 1516. Okay, 1516. The same thing, easy. The first one is 471. 471, insert it, and the last one is 597. Okay, you configure your all the I/O slot that is installed in your CANOPEN coupler. Now we can close the window. So the first thing we need to configure is the node ID of the CANOPEN coupler. Click here, and here's node ID field that you can enter or just plus these two bottom to add, increase or decrease the node ID. In this tutorial, I configure the CANOPEN coupler as ID 3, so it's 1, 2, 3. Okay, thank you. Just save it. And then we need to configure SDOS, server state object of the CANOPEN coupler. Go to double click the 750347, your CANOPEN coupler. Go SDOS, and here's the bottom add SDOS, SSU, and you can scroll down. You find a items called analog input global interrupt enable. Actually, if you find if you read the menu, then you know this is the item that to prevent the coupler to be memory overflow. So the analog input signal is default as false. You will not disable all the analog signal to prevent the memory overflow. But in our tutorial, you'll use the analog input module, so we need to enable it. Let's choose this index and press OK. And now this STO is insert in your project. And click the value field. Just enter 1. Finish. You've done it. Okay, now we can create our program. Go to application tree. Oh, maybe you can save it one time first. Go to application tree and open your GVL. Then you can define your variables here. For example, the first one is slot 1, right? Slot 1, it is a byte value. Slot 2, also a byte value. Slot 3 is for channel analog input, so array 0 from 0 to 3, 0 to 3 of what of word, and then slot 4 slot 4 same as array, but because it's the 8 channel of analog output, just enter 7 here. Okay, done. Then build it. Then we can create some logic to trigger it. Okay, in the main project, in the main POU, you can define some bit, B1 maybe. B1, B2 is a boot type, and current value is a view type. Okay, I want to know the first channel analog input value, so I use value is equal to underscore to view. I need to change my first channel of analog input to view first, right? So it is slot is GVL dot slot 3 0, the first channel, right? First channel. Now change to view, right? We can delete 32767.0. Then here, here. Then file needed to multiply by 10. We need to change the unit from analog signal to 0 to 10 voltage. Okay, it should not have error. Good. And then now we can will configure output. So if B1, then okay. So what we'll do if B1, If B1, then slot 2 is equal to 0F. Yes, and B1 is equal to false. B2 is equal to false also. Otherwise, if B2, then the same thing. GVL doc slot 2 is equal to 16 is at F0, and B1 is equal to false, B2 is equal to false. Done. Okay, very simple program. Just build it to make sure no error that inside my program. Very good. And then go back to the device tree, and now we can link all these variables into the I/O modules. First of all, it is the first one, the input, right? Go to CANOPEN module I/O mapping, and variable, click it, and applications, GVL slot 1, done. Do the same thing as the slot 2 and slot 3. For slot 3, you need to define separately, so I choose the first one, and I will make the field a bit longer, and 0. Okay, that's what I need to copy it. 1, 2, and 3. Good. And the last one, CANOPEN module I/O mapping. Do the same thing, slot 0. Make this a bit longer, and 0. And then go to 1, 2. Oops. I hope there's some smart way in for mapping the variables. If you know some smart way, please tell me, or please just leave some comment in the comment side that let me know. Thanks. Okay, so all the variables are mapped, build and build again. Make sure no error in my project. Good, and save it. Now we can close all the unused windows, close all editors, save it, and click the My Controller. Now we can log in, download the program to our controller. Just log in it. Okay, try again. Done. Here is just a warning. Are you sure to do this operation? Alternate F to make sure to confirm it. And this, because this is not my first time to log into my CPU, I configured the username and password before, so I just enter my username and password in here. Enter. You want to log in? Yes. Okay, just wait a second. Yes. Okay. Boom, boom. It's still waiting. It's still downloading the program into the CPU. Because I'm using USB, it may be a little bit slow. Okay, seems this download is finished. Click the play button to run, switch my CPU to run mode. Yes. Okay, good. Now you see the CPU is run without error. And in the device tree, you can see my CAN master was in green icon, no errors. Go to the application tree, open here. Okay, you can see some value in analog input is inside. Yes, input. Now we open my camera. Okay, so here you see the Wago coupler. There's no error in the Wago coupler, and the connecting is okay. And the sorry for my camera quality is not very good, but the TM241 Schneider PLC is no error, and the CAN interface LED is turned on. First of all, I will just try to use this analog simulator to output 0 to 10 voltage into the first terminal. Okay, I just turn around 3.9 voltage output to the terminal 0, to the analog terminal channel 0. Go back to here, then you see it just similar value because I didn't make the calibrations. Sorry about that. And the next step, then okay, so now the analog input is okay. The next step, I will try to turn on some output. I just turn on the B1, that's double click it, right or value. Yes, now you see the value change to 0F. See my camera again. You see the first 4 bit is turned on and the next 4 bit is turned off. Good. Then do this next one again. Double click B2, right or value. Yes. Then open the camera again. You see the I make some wrong, I think. Okay. Oh, sorry. No, it's not 2. Oh, sorry about that. Then log in again. Yes, okay. Downloading the code. Okay, and turn on the P2 again, double click it, right all values. Yes. Now you see the value change to 240, it means F0 here. Open the camera again. You see the next 4 bits turn on. Okay, so it's not a very big or some difficult tutorial. It just show you how to configure a CANOPEN master with Schneider TM241 PLC, and I show you some tricky point with a Wago CANOPEN coupler. Is that you need to download the EDS file on their website and import into your engineer tubes, and don't forget to set the SDOS to 1. It's very important. If you don't set it, your analog input will not be updated anymore. Okay, thanks for watching the video. If you like my video, please take a like or make some comment inside. See you next time. Bye bye.